Okay, folks, so this is solving trigonometric equation. Thing is, I'm going to go through this here. So these are the four quadrants. So I'm just putting, so it's CAST, so cast is the way you remember it, and I'm putting a little plus sign beside them. So what it does is it tells us when we solve a trigonometric equation, it tells us where each of them are positive. So if you look at this one here, it's an A for all. So all of sin, cos, and tan are all positive there in that quadrant. This quadrant here, because it has an S in it, it's just sin that is positive in it. So cos and tan are both negative in that quadrant. Then this one here, tan is positive in that one because there's a T. So therefore cos and sin are both negative. And then in the bottom right one, cos is going to be positive, and then the sin and the tan are both negative. So that's all you need to really remember for a second. But what we need that for is when we look at examples like this. So I'm going to go through 3 examples here. So cos theta equals minus root 3 over 2. So we can see that cos is negative here. So because cos is negative, we're going to be looking at this quadrant here and this quadrant here. So our solutions to this equation will be in those 2 quadrants. So I'm just going to remember that it's negative, and now I'm just going to go and solve cos theta equals root 3 over 2, so as if it was positive. So root 3 over theta equals cos inverse of root 3 over 2. And you can use the calculator then in radian form, or you can look into the log tables. And in radian form then that's going to be 30 degrees. So that's pi over, in radian form it's pi over 6. So that's a reference angle then. So if we look at where our answers will be then, so because cos was negative, we said it's there, so we're looking at this quadrant up here. So we always draw the reference angle from the x-axis, so from the axis going across. So our angle then for our first solution would be, so that there is pi over 6. So therefore our solution would be this angle here. So if that's pi over 6, well then the rest of it has to be 5 pi over 6. So one solution is theta equals 5 pi over 6. And then the other one is if it's in this quadrant here. So again, we always draw from the x-axis. So that would create this angle all the way around here to here. So that would be pi plus another pi over 6. So that would be 7 pi over 6. So those are our main two answers then. But if you think about it, we just need to allow for if you were to go a full way around the circle then. So if you were to think about that angle 5 pi over 6, so that goes to this line here. But if you were to go again around the circle again and get back to the same point here, well, that would just be adding 360 on, or adding 2 pi onto it. So every circle is 2 pi, and then if you were to go around again and get back to the same place, that's another solution. So those are all counted as solutions, so we have to include all of those. So a general solution here would just be plus 2 pi, and then you put in an n or just some letter, so where n is equal to 0, 1, 2, 3 and so on. So no matter how many times you add on 2 pi onto it. So that would be the general solution. That's called a general solution for that one. And then this one, you just do the same thing, so plus 2 pi n. So you can just remember that you do 2 pi n. Now this question was it said at the end there for radians, but if it can say degrees equally, so if it had said degrees there, well then our solutions would have been, our reference angle would have been 30, because pi over 6 is 30 degrees, and then our solutions would have been 150 plus, and then you just say 360 times n, because that's just 360 is a full circle in degrees, and then our other one would be 210, because it would be the 7 pi over 6 one, that would be 210, so that would be 210 plus 360 n. So I'm just showing you what the solutions would be if it was in degree mode, because you can be asked to work out those as well. So our next one then is solve the equation. So it's sin 3 theta equals a half. So now you'll see that it's positive here. That the half is positive. Therefore, if you're looking in our 4 quadrants, so CAST. So sin is positive in this quadrant up here and this quadrant here. So we're looking in those 2 quadrants for solutions. So sin 3 theta is equal to a half. Therefore 3 theta is equal to sin inverse of a half. And then you can go to calculator again, or your log tables, and we're getting pi over 6 again. So same as the first one. So we have 3 theta is equal to pi over 6. So that's what 3 theta is in so it'll be in the first and second quadrants. So you don't have to go off and work out and try break down 3 theta into 2 theta plus theta, or use a different equation or formula to change it around first. You can just find 3 theta, but now we must, this is the important bit, 3 theta then would be equal to, so it's going to be pi over 6 if it's in the first quadrant, because it would just make this one here, which is 3 theta. But then if it's in the second quadrant, it'll make this one here. So that's pi over 6. So therefore this angle here to get to that line is going to be 5 pi over 6. So our 2 solutions are 3 theta equals pi over 6 and 3 theta equals 5 pi over 6. So if you're to think of the general one, then it's plus 2 pi times n. So you must create that before you divide across by the 3. So theta equals pi over 18 then, plus it'll be 2 over 3 pi n, and our other one will be theta equals 5 pi over 18 when you bring across the 3 and divide it, plus 2 over 3 pi n, and that's when n is equal to 0, 1, 2 and so on, and n is any number. So that's the general, they're the general solutions for it. Right, so find out all solutions then for this. So so 2 theta equals cos inverse of a half, and we know that it's negative now. So it's going to be, so cos is negative in the second and the third quadrants. Now see the way this is in degrees up here. So they ask us to give our answer in degrees this time. So cos inverse in degrees is 60 degrees. So 2 theta equals 60 degrees. And therefore 2 theta, that's 60 is a reference angle. So 2 theta equals, so 60 in the second quadrant then would be, because cos is negative, so if that's the 60 degrees, well it has to be 120 plus 360 times n, or to theta equals, so the other ones, remember C A S T, so cos is negative in the second one and the third one, so it would create this one down here. So if that's 60 in there, well then the whole angle around has to be 60 plus 80, so 240, so 240 plus 360n, and then we can get what theta is, so theta equals 60 plus 180n, or theta equals half of 240 is 120 plus 180n as well. And that's our general solution then for this. Now it does say though that n, or theta, sorry, has to be in between 360 and 0 here. So if you look back at the question, so if it's in between 360 and 0, well, let's find some values then. So we know that n is just any number. So if n is 0, well then it would just be 60 plus 180 times 0, wouldn't it? So it would be 60, so that's one solution. Then over here, theta equals 120 plus 180 times 0, so that would be just 120. So that's one solution, because it is in between 0 and 360. Now if n was 1 in the first one, it would be 60 plus 180n, sorry, 180 times 1, and that would be just 240. So that is a solution. And then if it was 1 over here, theta equals 120 plus 180 times 1, so that would be 300. So that is a solution as well. And then if you were to try 2, so n equals 2, so it's 60 plus 180 times 2. So 180 times 2 is 360 plus 60 is 420. So that would be a solution, but because it's in the question that at theta is between 0 and 360, well, it can't count, and then it's not going to count over here either. So theta equals 120 plus 180 times 2. So 180 times 2 is 360 plus 120 is 480. So that can't count either. So then if n was 3, obviously it's going to be something even bigger. So theta is between 0 and 360, so therefore our answers are in there. So our answers are 60, 120, 240 and 300.